Hello, good day everyone. You're welcome to another class. I'm excited you guys are here for today's class. Okay, so today we are going to be looking at some questions on the mensuration. So in particular, we are looking at solid shapes. All right, so before we commence the class, I want you to invite your friends. Let them know the class is about starting because it's been a while on here. Okay, so invite them, let them know the class is about starting. And don't forget the class is going to be interactive as usual. Ensure you get your writing materials very close to you. Get your four-figure table, your pen, and your calculator if need be. All right. Okay. So in the next few seconds, we are going to commence the class. Thank you very much. Okay, yeah, thank you. I want to believe you guys have invited your friends. You share the links with your friends. Okay, so we are going to commence the class. Now, don't forget as you are joining the class, make sure you say hi. Make sure you tap the like button. And if today is your first time, coming across this video, ensure you subscribe to this channel before you leave if you love what we are doing here. All right, so we're going to start with this first question here. Let's look at the question together. A sphere has a volume of 200 centimeter cube. What is the volume of a second sphere whose radius is a quarter of the first ball? Whose radius is the quarter of the first ball? I hope you understand that. Okay, we have the first ball. This is the first ball. Okay, it has a radius of, let's say, r. All right, so we now have another ball which have a radius which is quarter of this first one. So that means the radius here is r over 4. Okay, that's r over 4. Okay, all right, so that's now the volume of this has been given. Now the question now is get the second sphere, the volume of the second sphere, which radius is 1 over 4 of the radius of the first one. I hope we all understand the concept of the question. So now let's see, how do we solve this? Now the first thing is to look at the tone of the question. The question is talking about volume. So what comes to mind now is the volume of a sphere. So I must know the formula for calculating volume of a sphere. So what is that? We have volume of sphere is going to be 4 over 3 pi r cube. Okay, so this is the formula for calculating volume of a sphere. All right. Now, the volume has been given to be 200. Right. So now the radius is not given. So let's look at it. So let's plug in this one. So we have 200 equals to 4 over 3, okay, pi r cubed. So that is what we have. So now let us make this the subject of the formula, r cubed. Okay, so now, so this turns to 200. Now you just multiply both sides by the reciprocal of 4 over 3, and that's going to be 3 over 4. So that's going to be times 3 over 4. Okay. Now we multiply both sides as well by the reciprocal of pi. So that's times what? 1 over pi. Okay, that is equals to r cube. All right, so let's try and tidy up things here. Okay, 4 goes here is 1, and 4 goes here is going to be 50. All right, so now use this to multiply this, so we have 150 pi, 150 over pi. So that's what we have, equals to r cube. I hope we all understand that. Okay, so now let us make this to be the subject of the formula. So that is r. So we have cube roots of 150 over pi equals to r. So this is the radius of this first sphere. All right, the ball. So now we want to get the volume of this. So we need to get the volume of this. So don't forget the radius of this is 1 over 4 of the radius of this. Okay, so now let's see how I'm going to do that. Now we already know that this is cube roots of 150 over pi. Cube root of 150 over pi is the radius. Okay, let's take note of that. So now let's get the volume of the second sphere or the ball. Now, so what's going to be the volume? So we have volume still remain 4 over 3 pi r cube. Okay, so 4 over 3 pi r cube. So we have the volume to be 4 over 3 times pi times r. Now, this is r. And what we have here now is going to be r over 2. So that r over 4. So we are dividing this by 4. And we incorporate it here. So that means we have this cube root of 150 over pi divided by 4 raised to the power of 3. I hope we all understand that. All right, because this is actually the radius of this new sphere. All right, so now let us take the cube of this. So when you do that, you have 4 over 3 times pi times, now when you find the cube root of a number, is going to give you the number inside. All right, so here we have 150 over pi, 150 over pi, okay, divided by 4 raised to the power of 3. So I can write it here, divided by 4 raised to the power of 3. Okay, so now this cancel this. Now 3 goes here 1, and 3 goes here is 50. Okay, so I have 2 now, 4 times 50, that is 200 times, now this is going to give you 1 over 4 raised to the power of 3. Okay, so now, and that is going to give you 200 over 64. 4 times 4, 16. 16 times 4, that's 64. We have 64. Okay, so we can reduce that. Let's see. Let's see, when we say 4 goes here, 4 goes in 200, that gives you 50. 4 goes here, that's going to be 16. Now we can divide by 2. Now 2 goes here is 25. And 2 goes here is 8. All right, so that means the volume now, okay, so it's going to be what? That's 25 over 8 centimeter cube. All right, so I hope you all get that. All right, so before I move further, if you have any reservation based on what you have question based on what I just did here, so let me know in the comment section. All right, so that is what we have for that. Okay, so yes, any question based on what I have on the board? If you have any question based on that, please drop in the comment section. All right, any question? Okay. All right, okay, so if there's no question based on what I have there, so we can move down to another question. And let's look at another question. Yeah, let's look at this. The next one, the density of copper used for a spherical ball is 8.9 kg per meter cube, and the radius of the ball is 3.5 centimeter. So calculate the curve surface area, the volume, and the mass of the sphere. All right. Now this is another question. So how do we solve this problem? Okay, so let's look at it together, and let's see how we can get a solution to this. Now, the density of copper used for a spherical ball is 8.9 kilogram per meter cube, and the radius of the ball is 3.5 centimeter. Now, you have to calculate A, curved surface area, B, the volume, and the last one, the mass of the sphere. Now, the first thing you have to get here now is curved surface area. Curved surface area. So I need to know the formula for calculating curved surface area of a sphere. Now, if you know the formula, can you drop that in the comment section before I give you the answer? Formula for calculating curved surface area of a sphere. Okay, so now if you know it, curved surface area. So what you're supposed to have now is going to be 4 by r squared. So that is the formula for calculating curved surface area of a sphere. All right. So now here we have the radius. The radius is 3.5 centimeters. So let's incorporate that here. So we get the curved surface area of the spherical shape. Now, so we have that to be 4 times. Now, pi is 22 over 7. We have 22 over 7 times. Now, the radius, 3.5. So I can write that as 7 over 2. 7 over 2 is the same thing as 3.5. So 7 over 2 times 7 over 2. Okay, since we have r squared, so we have 2 of that. Okay, so now this we cancel this. Okay, so this cancel this to be 2, and these 2 also cancel this. Okay, so what we are left with now is what? So 7 multiplying 22, and that gives you what? 154 centimeter square. Okay, so that's going to be the answer to that. Okay, I hope you all understand that. All right, so now let's move down to the next one. You have to get the volume of this spherical ball. Now, what's the formula? Volume is 4 over 3 by r cubed. That is the volume. That's the formula for calculating volume of a sphere. So now, can we incorporate this? So we have volume. Volume equals to 4 over 3 times 22 over 7 times, now what is the radius? We already have that to be 3.5, right? So we can have 7 over 2 times 7 over 2 times 7 over 2. Okay. All right, let's see how far we can go with this. So now, since it is raised to power of 3, so we have 3 of 7 over 2. All right, so this one cancel this. So 2 cancel 2 here. We have 2. 2 cancel 1, 2. So 2 cancel this to be 11. All right. So now, so what are we left with now? We have 11 times 7 times 7 over 3. Okay. So, and that is the same thing as 11 times 49. Okay. 49 over 3. Okay. So now let's multiply that. We have 49, so we have 935, okay, over 3. All right, so now this is going to be in centimeter cube. So this is the volume of the sphere. This is the volume, that is 539 over 3. So you can simplify that, make, so when you simplify that, what do you have? 500 and so divided by 3. So you have a decimal number, so that is 179.67 centimeter cube. So that's what you have for that. Okay, so the last part of this question, you have to calculate the mass of the sphere. Okay, the mass of the ball. That is what we want to get now. Okay, So how do we get the mass? So we have to quickly recall that density is mass over volume. Density is mass over volume. So density of a material is the mass per volume. All right. So now in this question you have been given the density. What's the density? That's 8.9. So we can plug that in here. So we have 8.9. We want to get the mass. So mass of the sphere over the volume. We have calculated that before. So that's going to be 179.67. Okay, so you cross multiply. So we have mass will be 8.9 times 179.67. So when you do that, okay, can we do that now? So when you do that, what do you have? So you can compute that and drop your answer in the comment section. So what I have here is 1,599.03 kilograms. So that's what we have. So this is going to be the answer to the problem. All right. Okay. So I hope you all understand that too. That's how to get the mass of the sphere. All right. So any observation based on what we have done? So if you have any observation, please, can you drop that in the comment section? Let's see those that have observation based on this. Okay, so if we don't have any observation, can we move on to the next thing? All right, so don't forget, if today is your first time, joining this class, ensure that you subscribe to this channel if you love what we are doing. Anyway, right? So, and make sure you tap the like button. Okay, so let's take the next question. All right. This is another question on the pyramid. Okay, so let's look at it. Now, if the volume of a rectangular based pyramid is 70 centimeter cube and its base area is 28 centimeters square. Now you have to calculate the height of the pyramid. So it's a very simple question. All right. So, since it's a rectangular prism, so it's going to look like this. You have your rectangle, which is the base. So, and you have it this way. Okay. All right. So, the height is here. I'll call that h, and the area of this rectangle has been given. So the what? Area is 28 centimeters square. So we are also given the volume. The volume is 70 centimeter cube. So you have to calculate the height of this pyramid. So now what is the formula for calculating volume of a pyramid? Do you know that? Please drop that in the comment section. Let me see if you know the formula for calculating volume of a pyramid. Before I give you the answer, just pause the video and drop your answer too. If you get the answer, let me know. Now you have volume equals to 1/3 of base area times the height. Okay, and the height. So that is the formula for calculating volume of a pyramid. So now here you have the volume to be 70, and there's 1/3 of that's 28, okay, times the height. Okay, so now we have 70 equals to, now 3 goes here, 3 goes here 1, and 3 goes here is what? 3 goes here is 8. Okay, so I hope that is correct. So now that is going to no, that is, will it completely go? So it will not completely go. So we are still going to have a remainder. So now let's do it this way. Now let's do it this way. 28h. Let's call the height h now. So this, we write it this way. Right, so we can cross multiply. Let's cross multiply. So we have 28h equals to, now use this to multiply this. Now 3 times 70, that's 210. Okay, so can we continue here? So we have h equals to 210. So you are dividing both sides by 28 since you want to find the height. So over 28. Okay, so now what do you have? Now can we try and simplify this? Let's see what we're going to have. So when you do that, we have 210 divided by 28. So what do you have? So that is 7.5. So that is 7.5 and 7.5 centimeters. So this is going to be the height. So that's the height of the pyramid. Okay, so any question based on that? If you have any question based on how we got this, or you have a reservation, so please kindly drop that in the comment section before we proceed to the next question. Okay, so I want to believe every one of you is catching up with the class. So let's take this next question. Okay, yes, this is another interesting question. Yes, let's look at it. How do we go about this? Yes, the question says the altitude of a right circular cone of base diameter 6 centimeter is 4 centimeter. So you have to find the slant length, the total surface area, the volume of the cone, all answers to 3 significant figure. Okay, so now let's see, let's sketch the diagram for that. The cone in the question, we have an altitude, which is the height, and we also have the radius. So, but in the question, we are given the diameter. Now let's look at it. Now the altitude of a right circular cone of base diameter 6 centimeters. So that means we have the diameter to be 6 centimeters is 4 centimeters. So the altitude is 4 centimeters. I hope you understand that. All right. So now from here you can get the radius. Radius is diameter over 2. So radius is 6 over 2. Radius is 3 centimeters. So you can just write R is 3 centimeters here. Okay. All right. Now the question asks you to find the slant length. The slant length is this. This is the slant length. Now to do this, now look at this. This is a right angle triangle. You can see a right angle triangle. So let's bring out this right angle triangle. Okay. So here we have 4. Here we have 3 centimeters, and this is L. So we are going to be making use of Pythagoras theorem. Now, the square of the two sides, when added together, gives us the square of the hypotenuse. So we have L square equals to 4 square plus 3 square. So L square equals to 16 plus 9. So L square equals to 25. Okay. So we have L equals to square root of 25. And that gives you what? That is 5 centimeters. So that means the slant length is 5 centimeters. But look at the question. The question says all answers to 3 SF. So if I'm converting this to 3 SF now, so slant length will now be what? 3.00 centimeter. So now this is going to be the answer. All right. So many students will make mistake. They'll just like, okay, 5 is the same thing as 5.00 centimeter. The question says all answers to 3 SF without exception. So we have 3 answers here. We must get 3 answers here. So the first one is this. Okay, so and it must be expressed in 3 SF. So we count 1, 2, 3. So we count 3 digits. So that is the answer to that problem. I hope you all understand that. Okay, good. So now what it means now is that if someone stopped here and did not write the answer like this in 3 SF, that person is going to lose a point. So you lose a point if you don't write it in 3 SF. So now let's look at the second part of the question. You have to calculate the total surface area. So the total surface area of this cone is going to be the curved surface area plus the area of the circle underneath. So can we do that now? All right. So don't forget this one is 5. Slant length is 5. Okay. So we have this to be 5 centimeter. Okay, total surface area of the cone is going to be the curved surface area, that is pi RL, plus the area of the circle, that is pi R squared. Okay, so I can simply write this formula this way. Pi r, just factor out pi r, we have L plus r. See the same thing? Okay. So now let's plug in the values, the radius and the slant length. We have gotten the slant length before. All right, so we have this to be 22 over 7 times 3. Okay, radius is 3 times slant length, that's 5 plus 3. Okay, so that gives you 22 times 3 times 8, everything over 7. Okay, can you compute this and tell me what the answer is? All right, so compute 22 times 3 times 8 divided by 3. So what do you have as your answer? So if you got your answer, please drop that in the comment section. Let me see what you have. Make sure you are doing something. So this will be the first assignment I will be giving you today. So who is the first person that is giving me the correct answer? Okay, so compute that. 22 times 3 times 8 divided by 7. Yes, anybody? Okay, I've not seen anyone dropping the answer. It's not supposed to be difficult to do. Yes, is there anybody? All right, okay, good. Riscott, I've dropped an answer. That's good. So, okay, it's only Riscott that I can see here. Is dropping an answer. We are others. Okay, so let's follow what Riscott has given. And that happens to be the correct answer with what I have here. That is 75.4285 centimeter square. Okay, so this is the total surface area. Now, but the question says all answer to be what? 3 significant figures. So the total surface area now, you count 3 digits. This is the first significant digit, 7. So you count 1, 2, 3. Okay, so this way you are stopping. So that means your answer now is going to be 75.4 centimeter square. So this is to 3 significant figures. So if anyone stop here, you will not get the final mark. So the final mark will be awarded here. So you must correct it to 3 significant figures. So I hope you all understand that. All right, so now let's look at the last one, the volume of the cone. The volume of the cone. So how do we get the volume of the cone? All right, so what's the answer to this? This is 75.4 centimeter square. Okay, so what of the volume? All right, so the volume of the cone, we have volume equals to 1/3 of pi r square h. Okay, 1/3 of pi r square h. Now this is the volume of a cone. That's the formula. Now let us import the values and let's see what we're going to have for the volume. So let me give you a minute now to do that. So I'm giving you a minute now to tell me what the volume is and we do it together. So what is going to be the answer to this? All right, so find the volume of this cone. So if you have your answer, you can drop your answer in the comment section. Okay. So I'll be waiting for this short answer to your sis answer. Show me this answer, Adebukola's answer, and others. Okay, multivariate answer and others. So what is the volume of that core? So I expect every one of you now to be rounding up by now. You should be rounding up. Okay. The volume of the cone. So just input um, the values and you tell me what you have as your answer. Yes, is anybody with the answer? No, okay, yes. Riscott have dropped an answer that is 25.14. Okay, 25.14 centimeter square. Okay. Any other person with another answer? Any other person? All right. Okay, so now let's move forward. Since someone have given an answer, so let's see, let's confirm. So if you are still doing it, once you have your answer, you can drop it in the comment section before we finish this. Okay, or better still, you pause the video and you do your own and then you drop your answer in the comment section. All right, so let's see. Now, the volume equals to 1/3 of pi. Pi is 22/7, okay, times r. R is the radius. So r squared, that's going to be 3 times 3, okay, times the height. What is the height? 4 times 4. Okay, so now this will cancel this. So what we have left now is going to be 22 times 12, everything over 7. Okay, so now can we do that? So when you do that, for the numerator 22 times 12, you have 264/7. And when you divide that by 7, so what you have now is going to be 37.71. Okay, so that's what you're going to have. All right, so that's what you're going to have for that. Okay, so can we now correct to 3 significant figure? So you count 3 digits, 1, 2, 3. So that means our answer is going to be 37.7 centimeter cube. Okay, so that is going to be the volume. That's the volume. So we write this to be 37.7 centimeter cube. So, and that is the answer. Any observation based on what we have here? Okay, so any observation? So if you have any observation based on what we have there, you can drop your answer or your observation in the comment section. Yes, okay, all right, okay. All right, Rick Scott, I've seen your new answer. Okay, so I guess you miscalculated before. Okay. All right, so that is how you're expected to solve this question. All right, so we are going to be hanging here. Okay, so tomorrow is another day, so we are going to treat more questions, and it's going to be WAEC based question. We are going to look at different questions most students run away from. I want you to be available for tomorrow's class. Okay, so same time, right? And don't forget, if you are new on this channel and you love what we are doing here, ensure you tap the like button and you also click on the subscription button so that you'll be notified whenever we are on here. All right, so I want to believe you guys learn one or two things. Thank you very much for watching. I'm so much excited that you are there. Thank you. Bye-bye.